Welcome to the solutions video for IXL Skill 12 B.3, or specifically dilations of functions. So what does this transformation do to the graph of f of x? Is it going to shrink it horizontally, stretch it horizontally, do it vertically? Well, we don't know what graph f is, so this has to be the general transformation. So this is altering our x values because this 1/7 is acting directly on the x, so that makes it horizontal, and it's going to shrink it because stretch it, because what used to happen between 0 and 1 now happens between 0 and 7, because x equals 7 is where this function's input is back to the one it was before. Now this is going to shrink it horizontally. Replacing x with 2x means what used to happen at x equals 0 still happens at 0. What used to happen at x equals 2 now happens at x equals 1. Because when x equals 1, the input of this function is 2. So this will be a horizontal shrink for the same reason. What used to happen at x equals 6 is now 1, but the 0 happens at 0. Now the 4 is acting outside. So when y is 0, we still have 0. When y is 1 in the old, we now have 4. So this is going to stretch it vertically. Inside a fraction is less than 1. That's going to be a horizontal stretch. It's outside and less than 1, so it's a vertical shrink. Outside less than 1, vertical shrink. Outside greater than 1, vertical stretch. Inside greater than 1, that's a horizontal shrink. Outside less than 1, that is a vertical shrink. Now, what kind of transformation converts the graph of negative 10x plus 9 into negative 2x plus 9? The plus 9 hasn't changed, so we don't have something outside multiplying the whole f of x. All we've done is multiply x with 1 over 5. That's what it takes to turn negative 10 into a negative 2. So this becomes a horizontal, it's a horizontal change, and it is a horizontal stretch because that fraction is 5, or 1 over 5. So you multiply it by a number whose absolute value is less than 1. Now here the entire thing has been multiplied by 7, constant and coefficient. So it's like replacing f of x with 7 f of x. That's a vertical stretch. So now all of our coefficients have been divided by 2. So we multiplied f by 1/2 f. That is a vertical shrink. Now here we have to be careful. Our constant is negative 2 in both cases. So whatever's happening is acting only on the x, but this is x squared. So we replaced x with 2x to produce a 4x squared. So this is a horizontal shrink. We've multiplied x by a number greater than 1. Here the entire thing has been multiplied by 6, constant and coefficient. So that is replacing f of x with 6 f of x. That's a vertical stretch. Now here we have divided everything by 2. That's a vertical shrink. Here we have multiplied everything by 5, vertical stretch. Divided everything by 2 is a vertical shrink. Now here we've just divided the coefficient of x by 6. So x has been replaced with 1/6 x. That's a horizontal stretch. now we've divided everything by 7, vertical shrink. Now here, we have to be a little careful here. So our 3, so the coefficient of x has been replaced with a 6. If we were to multiply this through, we'd still have an 18. So effectively, we've replaced x with 2x and made no other changes. We have to do a little bit of algebra to see that. Right, but because these are positive numbers, we could multiply them through without affecting the absolute value. So this is the absolute value of 3x minus 18 minus 4, and g of x is the absolute value of 6x minus 18 minus 4. So that is the same as replacing x with 2x. That is a horizontal shrink. Now here, the entire thing has been divided by 3. What's inside the absolute value has not changed. The 6 becomes a 2. So that's a vertical shrink. Now here, just the coefficient of x has been divided by 4. So we're replacing x with 1 over 4x. That's a horizontal stretch. And hopefully, finally, our constant has not changed. If we were to multiply our negative 10 inside the absolute values, it would be now a negative 10 plus 4, or negative 10x plus 40 inside. And this would be a negative 5x plus 40 in the second one. So we've effectively replaced x with 1/2 x. That's a horizontal stretch. We could graph these as well if it helps us to picture them.